Now I'd like to introduce Dr. Mark Kelman. Mark is a veterinary scientific researcher and social philanthropist who graduated from Murdoch University in 2000. His career has spanned work at the RSPCA New South Wales, general practice in Sydney, technical manager for veterinary pharmaceuticals, and currently he's pursuing a PhD in canine parvoviral epidemiology. He is also the co-founder and director of Pause for a Purpose, a social enterprise charity for people in need and their pets, and he's a board director of Pets in the Park, a charity helping the homeless to care for their pets. And I personally think he's going to end parvovirus in Australia, but that's just me. Anyway, so here is Dr. Kelman. Thank you.
All right, let's hope the clicker works better for me. See how we go. Great to see everyone here today. It's an amazing turnout. Quick raise of hands, who was here 2 years ago? Awesome to see you guys back. Obviously, we're running this thing okay, that everyone's coming back. That's great. I was very fortunate to be able to give a talk about this project 2 years ago. So for you guys who were here before, be able to give you some feedback as to the progress that we've made in the last 2 years. I'd love to come back in 2 years' time and tell you what we've done by then. But yeah, like I said, great to see everyone here today. And when parvovirus, another quick show of hands, who here has been exposed to parvo? I'm guessing it's most people in the room, yeah. So for those who've been fortunate enough not to see this virus, you're very lucky. Hopefully you won't. The likelihood is that if you continue in this space, you probably will. It's just one of those diseases that is such a terrible virus, and puppies obviously can suffer so badly from being exposed to it. So the goal today is, like I said, to give you guys some information about the virus itself, but more than ever just to try and let you guys know the kind of work that we're doing to try and stop this thing across Australia. So Parvo, interestingly, is a relatively new virus. It's only been around for just close to 40 years now. So like myself, 40 years young. And even though it's a relatively new virus, it's obviously done a lot of damage over those years. And the reason why it's so bad is that in the animals that it affects very severely, it has, terrible clinical signs. These are little puppies that often catch the disease. They get horrible vomiting and diarrhea, gastroenteritis, dehydration, immune suppression, and they can die as quickly as in 24 hours. And they die in a lot of pain and suffering. And for the people in the room who've seen this virus, you know that it's something that you'd never wished on anybody or any pet. It's just a truly tragic thing. One of the other real issues with this thing is that we also tend to see not only just the high rate of death from the disease, but also high euthanasia related to the disease as well. A lot of the puppies that catch this virus, and obviously in the shelter environment where you're concerned about disease spread, just catching the virus, being diagnosed positive, is enough reason for many vet clinics and many shelters to euthanize animals as well. So if we can stop this virus, hopefully we can stop a whole lot of deaths occurring too. The last couple of issues we see is obviously that as well as being terrible, the virus can be carried subclinically or asymptomatically, which means that a puppy can carry it and we don't even realize. Obviously that makes it easier for it to be spread. It also persists in the environment for quite a long time. Not as long as some people think, but certainly 6 to 12 months, the virus certainly can persist, which makes it very easy to spread. And like the earlier discussions today, it's one of these viruses that because it's so hardy, you can carry it on your shoes, you can obviously carry it on your hands. The virus can literally travel, probably 100 kilometers, on vehicles. It's such an easy thing to spread from community to community. We've even heard case after case of dogs that never leave the farm coming down with the virus because obviously it's entered the farm from being in the local area. We hear cases of puppies, and obviously there's cat parvo as well, so puppies and kittens carrying this parvovirus being transported for the purpose of rehoming and then seeding new cases in new environments. So it truly is a tragic thing that we're obviously very keen to try and get rid of. So in some of the research that has been done over the last 10 years, which I've been involved with, and a lot of this research, the research area, like Anne said, I'm involved with is called epidemiology, which is the science of how diseases spread. And even though we know lots about parvo in terms of its microbiology, so what the virus looks like and what its DNA looks like, there's been very little research done in actually how it moves within populations, what are the risk factors. So a lot of the research I've done in the last 10 years has been around some of this epidemiology in Australia. Most of it does apply for other places in the world as well. And we've been able to discover things like that there is a predisposition in both the rural and regional areas, but also the socially disadvantaged areas as well. We do know that outbreaks obviously occur generally with some seasonality, so year after year they occur around similar times, not always the same time, but certainly around similar times. And I don't know whether you guys have seen this too, but certainly it's reported, and we hear this a lot, that it seems to come either immediately after a lot of rainfall, so whether it's floodwaters or a lot of rain, you tend to get parvo cases occurring, but sometimes also after an extended dry period as well. And obviously with Australia being in a drought, we are definitely hearing more and more cases coming through in these areas where they haven't seen rain, and we think one of the reasons might be if it's building up in the environment, but we're not truly sure exactly why these patterns are emerging. So the good news, there is one bit of good news, that is we have some really good vaccines. And the vaccinations seem to be around 95 to 98% effective. So we talked earlier this morning about giving the big numbers for good news. So 98% effective is great, but what that means is we can have 2% to 5% failure rates. And when you're in the midst of an outbreak, that 2 to 5% failure is really important because these are the ones that are actually still going to catch the virus even though they've been vaccinated. But the good news is the vaccines work, so if we can use them in the right place at the right time, potentially we could stop this virus, and that's what we're trying to achieve. So with all of these things that we know, what do we still need to learn? And this is what we've been focusing on with this research. So the first thing that until now we haven't really understood exactly how many cases we actually do see across the whole country. This has never been studied before. Why are we getting these seasonal recurrences? You know, we think that there's some reasons, maybe it's puppies being born at certain times of year, but we don't understand exactly why we do see this seasonality. We don't know why there's this association with, you know, flooding and rainwater. Again, it's something that we've been able to show statistically, but don't know necessarily why it occurs. There's also a big question around whether wild dogs, you know, dingoes and so on, might be involved in disease transmission. So, you know, it obviously stands to reason. We know these dogs can catch and can carry the virus, but do they actually play a role in spreading the disease? And also, while we know there's a lot of research that's been done to show that there is a link with, like I said, social disadvantage, is it just because people who are in these socially disadvantaged situations cannot afford to vaccinate? Is that the reason why, you know, we're seeing these cases? Or are there other factors involved? And obviously as scientists, we don't make assumptions. We need to test everything to make sure that if we are going to make a change, it's going to have the right effect. And then the last question, this is the one that I'm really interested in. If we do manage to use, you know, effective disease surveillance and effective communication strategies, could this mean that we could use this to try and help stop the disease? And I believe maybe it's possible. And what we've set out to try and investigate is if we can identify all of the areas where we are seeing canine parvo, and at the same time, if we can discover what these risk factors are, what is it that's causing the disease to occur in all of these places? And if we can introduce ongoing effective disease surveillance and communication strategies, and if we can start targeted vaccination programs specifically targeting the socially disadvantaged areas, those people who love their pets so much but they honestly cannot afford to vaccinate, and they would if they could, if we can do all of those things, then is there a possibility that maybe we could protect all of these puppies that are catching the disease? And if that's the case, is it possible that we could actually stop the cases in these specific areas where we know that parvo is occurring? Could we then possibly scale such a program nationally all over the country? And could we reduce, which I believe we can, or possibly even stop parvo altogether? This is the goal. And the rest of this talk I'm going to fill you in as to the progress we've made so far, because like I said, this program's now been going for 3 years. Like Anne introduced, I'm in the midst of a PhD. I'm in my final year of this PhD. It's been a little bit of work, but it has been a lot of fun, a lot of blood, sweat and tears. Not all of it's mine. In fact, to be honest, I've had a lot of support. So many people across the community have helped to make this thing a success, which I'll be sharing. And obviously, it's been a great undertaking with the University of Sydney, to whom I'm very, very appreciative of all the help I've had. But let me share some of the research work that we've done and the progress that we've made. So, again, 2 years ago, we were just launching this. We just finished this survey. I just had some of the preliminary results at the time. But what we did was we managed to survey every single vet clinic in Australia. We had a range of volunteers, both veterinary students who volunteered, plus volunteers from a charity that I'd started, and myself. We all literally rang every single vet clinic and said, hey, can you guys do the survey? We got a 25% response rate, 23.5% response rate, which was amazing. And we asked them a whole lot of questions around how many cases of both canine parvo and the feline parvo that they'd seen. We asked questions on their vaccination protocols. We got some demographics. We asked about euthanasia rates. What were some of their attitudes and beliefs and perspectives around parvo cases. The vets who were seeing these outbreaks, we asked them what they did to try and help intervene, because that was going to be important for some of the intervention work that we had planned. And we asked some of their opinions on disease surveillance. So it was a pretty chunky survey, but to get this nearly 25% response rate was amazing. And some of the information that we found. So in 2016 and in 2015, it was very similar results. We found over 4,000 cases of parvo were being reported from these respondents every year. We knew that the data that we'd got was representative, because we managed to get people answering literally from all over the country, and you can see in the maps, that's a map of where the cases are, but the distribution of vets was also very similar. So we could extrapolate that data, and then we could see that it looks like 20,000 cases every year is how many cases of parvo actually occur. And from some previous work, we know what the mortality rate from parvo is. So we know about half of those cases will die, whether it's from euthanasia or whether it's from the disease itself. So every year, that's 10,000 little puppies that are suffering and dying from this disease. And that's what I want to stop. So part of this work is then, now that we have identified where these cases are occurring, we can start to see where these patterns are. So we're able to find that large numbers of these cases, in fact, one of the biggest risks was in these large regional centres in remote Australia. And one of the limitations of this work was obviously it was the vet clinics reporting. So what we do know is that we know where the vet clinics are seeing cases, but there's a lot of cases where there are no vet clinics. So we know there's a lot more cases than what we know, but even the ones that we know is still bad enough. So, we've identified that there's a real issue. The next stage is obviously to get out and to, find the areas that we don't know. What we do know, like I said, is that the large regional centres are a major problem. We know that euthanasia, 41% was the overall euthanasia rate. In some areas, it was 100% euthanasia rates from these vets. So, again, killing puppies and kittens is something that we don't like to do. It's having a terrible toll on everyone. And, this is something that I honestly believe we can make a change. And for the first time ever in the world, we now have an incidence rate, which was 4.12 cases per 1,000 dogs. So on average, for every 1,000 dogs, 4 of those are going to have parvo and 2 of those are going to die. And that's every year, which is crazy. And obviously in the areas where we see more parvo, that rate's going to be a whole lot higher. It's a good thing to have, because now we can compare it to other countries. We have a baseline. We know what we're dealing with. But it's only now that we have these kind of technologies we can start to get this kind of information. So that was just a bit around the geo distribution of cases. Like I said, there's a whole lot more analysis that we've done and that we're working on. The next stage was looking at some risk factors. And this is the areas that really interest me, because obviously knowing where the cases are is great. We can start these targeted programs. But knowing some of the risks means now we can start to be a bit more targeted even further in these areas. So the next stage was to look at socioeconomic data, remoteness area data and climate data. A lot of this came from the Australian Bureau of Statistics, and the rest were from the Australian Bureau of Meteorology. Thanks, Anne. And essentially, you spend months and months and months combing through all this data and eventually get some results. So it is really interesting, but it does take a lot of time. And I think the take-home message from all of the analysis that we've done is that socioeconomic disadvantage seems to be the biggest risk factor for parvo cases. So we know that remoteness is a problem, but a lot of these remote areas are socially disadvantaged areas, and we know how tough the farmers are doing, the remote communities are doing, not just because of drought, because there's so many disadvantages and obviously, drugs and social things. There's a whole lot of issues. So, the social stuff is a big factor. So hence, one of the reasons for starting the charity was to see if we could find social solutions which might be able to help us, make a difference to this problem. The social stuff isn't only for the number of cases, but it's also for, the cost of treatment, increased euthanasia rates. They're all factors that all seem to be involved with this whole issue, which is around social problems. For people who like graphs, this is just a quick graph to show that, the number of cases that we're seeing in the socially disadvantaged areas. So the number 1 represents the most disadvantaged, number 5 represents the least, and the little black bar in the middle represents the median or the middle number. And so you can see that in the most disadvantaged, you're seeing more cases, and in the least disadvantaged, you're seeing less cases. And again, this is just an interesting pattern that, although we probably all knew it before, it's nice to really be able to prove it and prove it with some good data. So the next area we looked at was around the recurrence analysis on parvo cases. And this is interesting because, again, this stuff has never been done before. We've always tended to look at parvo as being a disease of individual dogs, and the reality is it's a community disease. It's a disease that obviously, spreads in the environment. And so the questions are, what's happening in these different communities that's causing the spread, and hence, once we can understand that, how can we make a change? So I'm just going to share today a little bit of data from two of the suburbs, two of the towns that we've analysed, Rockhampton and Wagga. So again, they're large regional centres. They're areas that have been identified as parvo areas. And in this case, the veterinarians actually went through all of their data. They spent a lot of time, and obviously we're really in debt to the amount of time they've spent identifying all of the cases and sending the data through. And they've given us data for at least 2 years. We've done this for some other areas as well. We're also collecting more data to get even more information. So this is an ongoing thing, but even this alone is quite interesting. So what you can see, this is the data for Rockhampton. And you can see here that we have data for 2016, 2017, 2018, and a little bit from the beginning of this year. And the whole goal of this is to identify when are these cases occurring so that if we can start doing some targeted vaccination programs, when we need to start to have the most effect. Because if we're not running the program for the whole year, you want to start maybe a month or two before you're likely to see cases. What's interesting is if you look at the orange and the blue, which is obviously 2016, 2017, they were the worst couple of years that this particular town had had. In general, say November to around January seems to be when most of these cases are occurring, but it doesn't always occur at the same time. So obviously 2016 was a really bad year, and this happened, 2016 across the whole of Australia was really bad. We're not quite sure why, but it was, again, you guys might remember that far back, was particularly bad for parvo. But for some reason, they're seeing, some clusters of cases, some outbreaks, and around sort of the autumn to winter sort of period, but again, also in that spring-summer period as well. So we don't know exactly what the triggers are, but again, we can do more local research now that we know that these patterns are emerging. And the next slide is then looking at Wagga. And again, Wagga is a little bit sort of same as different, if this thing comes up. Here we go. And again, Wagga sort of sees cases all year round, but again, the same thing, around October to around January seems to be when they have the highest risk. So we've been doing some vaccinations in Rockhampton, which I'll talk about a bit later in this presentation. Wagga we're looking to start, but knowing that we're coming into this high-risk time, we're hoping to be able to get started soon and see if we can make a difference for the cases that we're already interpreting are going to recur, very, very soon. So the next part of the research, like I said, one of the questions that's never been answered in Australia is whether parvovirus can be spread by wild dogs. And I was very fortunate. I was talking at an RSPCA conference, I think it was last year or the year before, and I just happened upon a researcher who'd actually sampled some wild dogs for her research but didn't analyse parvo. So I was able to get that data and have a good look at it. And we could analyse this for the parvo in those wild dog samples. So we're able to look at the wild dog samples from northern New South Wales and Queensland, and using a technique which is called PCR, which is polymerase chain reaction. Don't worry about the name, but basically means that we can look at the DNA, which is the genetics, to identify whether parvo is present in a tiny sample. And it looks like 5% of these dogs have been exposed to this disease, which is really interesting. So knowing this, we're now able to look at some data so we can actually sequence the strains. And so we know the particular type of parvo that was caused. And now what we're doing is we're comparing that against a genetic bank of information that's been collected over the last few years of different parvo cases all over Australia to see if there's a relationship between these cases. And if we can show that, then we can potentially see that maybe the wild dogs are either spreading the disease or potentially catching it from domestic dogs as well. And again, this is just another piece of that puzzle that might explain the recurrence of cases that we're able to see. Now, I have been moved on a bit, so I'm just going to go a bit quicker through these. We did also ask the vets about questions on their behaviours and understandings around disease surveillance. And the good news is that vets are very keen to help in disease surveillance. The main thing is we've got to tell them that this stuff is being done, but they're very keen to contribute, which is really good news. And so what we've started now is a disease surveillance program for Parvo. The previous disease surveillance program, which I also created, which worked for nearly 10 years, was finished back in 2017, which opened the space for a new program to be created for Parvo, which has actually gone live today, which is really exciting. So you guys are the first people ever to hear about this thing being live. Thank you. And it's called Parvo Alert. And based on the feedback the vets gave us, we've designed it to make it easy to use. The system, or the mapping we've just started to work, it's going to be able to graph the cases as well, so we can actually see outbreaks occurring in a graphical sense, but it'll also have the potential to send alerts to people, so you can set alerts into the system. So you can say, look, tell me when an outbreak starts in this area. It'll actually email you to say, look out, Parvo cases are increasing. So it's got this huge potential to have this amazing impact, on actual Parvo that's happening, in real time, in real life. And obviously the data is going to be available for great research purposes as well. But the whole point is to get this thing started and just to keep improving it. So, the one that we've released today is literally the very first beta test sort of level. And, I hope you guys will all log on to it. I'll give you some details shortly, but it certainly has a long way to go, but it's something that we're developing, with the aim to make this really, really great. And there's so many different things we can do. I don't have time to tell you all the interesting stuff that we're doing, but there's a whole lot of research being done on the back end. So we're going to have plenty more to talk about in 2 years when you guys have the next conference. But you can register for this at www.parvoalert.com. So I do encourage everyone to log on and register. It is available now. And everybody will have access to the mapping, the ability to do the graphs and to see the alerts. The vet clinics currently are the ones logging cases. Potentially down the track we could open up to others as well, but to start with it's got to be for the vets. But the potential for this to be huge I think is really, really good. And just a couple of quick screenshots just to show you through. So this is just a picture of the front page. You can scroll down, you can see the maps. And this is just how the vets log. So it takes them literally about 20 seconds to log a case, which is really easy. And then that's just what the mapping is going to look like. But there's a bit more coming through as well. So I don't know how much time I have left. I think I'm pretty close, Anne. But the last thing I want to talk about is just around some of the intervention projects we're doing. So like I said, the charity Pause for a Purpose was started. Its main focus at the moment is doing this Parvo research. It does other things as well. It's amazing to sort of plant the seed of these things and watch them grow. But the vaccination programs is really, really important. And basically what we're doing is we're providing discounted vaccination for people who are socially disadvantaged. So they're qualified by being on a pension card or a healthcare card or a New Start allowance. But essentially the people who, they come to us and they say, look, we want to get our pets vaccinated. We just can't afford it. We love the pets. How can we help? So the first project we did was a pop-up veterinary clinic, a pop-up vaccination clinic, where we basically had volunteers running it. The charity paid for the vaccines. The people would pay $15. If they couldn't afford $15, we'd still do it for free. Most people were very happy to pay $15, which made it sustainable. And we did the first one in Rockhampton. We're able to vaccinate nearly 400 puppies over the course of 4 months, which was great. 1 month we couldn't go because Rockhampton was on fire. I had to push it back a month. And sadly, that was when Parvo started as well. But thanks, Anne. But yeah, that was definitely a success. The next pilot that we're doing is looking at a different system, which is actually using a voucher system and a subsidy where the council is providing some money, the charity is providing some money, we're doing some more fundraising, but essentially we can then send people directly to the vets, because the hardest thing with the other model was just that the vets are exhausted because they work so hard already. Getting them out on the weekend to do something for free is really hard. So just show you a couple of happy snaps of, if it comes through. Doesn't, there we go, whoops. It's probably time to finish up anyway. So, stumped at the end by the clicker. This is going to fuss me off. There we go, it's not meant to be. Thanks guys, I'm sure we're going to have questions now anyway.